Hello to everyone. With another Istanbul Aydın University Blockchain Academy Blockchain Talks. We have a very important speaker today, Professor Ahmed Banafa from San Jose University. And before I announce his title, I could tell that Professor Banafa is very important in blockchain, and he is really one of the thought leader in this digital technology and mostly in blockchain. And he will share his view today in 10 impactful technologies in 2023 and blockchain entrepreneurship. So please, Professor, the floor is yours. We are looking forward to listen to you. And before you start, we are very thankful that we know you are talking to us from USA, and I know it is very early at your place where you are. Thank you for dedication, and the floor is yours.
No problem, no problem, Erol. And I'm really happy to be here, and thank you so much for the invitation. You're a very good friend, and I'm not going to say no to you. Besides, it's an honor to be, in this university. It's really something that I was looking for the past few weeks. So welcome everyone to this webinar. I'm going to share my screen with the presentation, and then we can start going through the 10 impacted technologies. Just give me a second. Okay, I'm going to go full screen, and then okay. I think everybody can see my screen now, correct? Okay, I can see that. Okay, fantastic. Okay, so the title of the webinar is talking about the 10 impactful technologies in 2023 and beyond. And the reason for me to have something like this presented is to show you what I think it's going to be the technologies that will direct change and and improve our future in the coming years. Before I start talking about this, and let me talk a little bit about myself. It's going to take about a minute to show you my interest, and then we can jump into the topic of today's webinar. My focus is in 4 areas in the research where I teach at the University San Jose State in San Jose in California. It's the Internet of Things, blockchain, cybersecurity, and AI. Very active on LinkedIn, and you can see on the side that I have some interviews on the media, and this is the reason. The reason for that is because one of the things I do at the university is something called media expert. As a media expert is somebody in the university who will answer the question of the school, of the question of the media about any new technologies, something new in the technology. They contact the university, and then the university direct them to one of the professors in that field. My for me, my background, educational background, my undergraduate was in electrical engineering, my master's degree was in electrical engineering, and my PhD is in artificial intelligence. I published multiple books, and the first book was in 2018, Secure and Smart Internet of Things Using Blockchain and Artificial Intelligence. It's actually won multiple awards, and the Library of Congress have it on their shelves. It's on 600 university. You can see the names of the university that is have copies of my book. The second one was the blockchain technology and applications, and this one is used in some of the courses at Stanford, and it's on the shelf of 520 universities. The third one, which published last year, which is the quantum computing, and I taught quantum computing at multiple universities, and it's on the shelves 120 universities. The last slide is the forthcoming books. I have 4 books. It's going to be published by the end of the year. Introduction to Blockchain, Introduction to Quantum Computing, Introduction to Internet of Things, and my favorite book, which is Transformative AI, which is talking about the current situation of AI and how the AI is changing so many things in our lives. Okay, so that's that's about me. That's about my background. Let's talk about the 10 impactful technologies. Now, there are many exciting technologies that we see, we live through, we have them, and we are using them. But some of them have a big impact than others. And when we talk about those technologies, we're talking about something like this. And this is just to summarize the webinar. The 10 impactful technologies that I believe that will have a big impact on the future of technology all over the world, not just talking about the United States or talking about Silicon Valley, where I'm stationed. Generative AI, it's a big name and everybody's talking about it. It's not something that is new. VUI, which is voice user interface, is another way for the system to interface with the users. Edge computing, it's been one of the hottest areas in the field. 5G, we've seen this, and this is something that a lot of people can relate to. And the XR, which is a combination of a VR and AR, it's a virtual reality and augmented reality. And of that, the increased use of chatbots, and I'll talk more about it. And quantum computing is another area. And digital twin, it's well known in the industry. And then we will talk about the distributed ledger technology, which is another fancy name for blockchain, and then Internet of Things. Definitely, there are other technologies that could have impact on our lives, impact on the industry and the business. You can add them to that to the list, but this is the ones that I feel their impact will be immediate, and it's going to continue as we grow and as we advance. Let's talk about the first one, which is the generative AI. When I'm talking about the generative AI, we have to distinguish this from the traditional AI. And I'm going to talk more in depth about AI and the types of AI and the levels and the stages of AI. Generative AI is basically look at the contents and generate new contents based on what that program learned, compared to the traditional AI, where it's designed to analyze and interrupt the existing data by saying that this related to this should be the case. The generative AI, from the name, is generating new data, generating new information, as if you have somebody, you train that person, and that person going to make his or her decision based on whatever they learned. And that decision could be completely different from whatever they learned. Why? Because this is how they develop their way of thinking. And this is the driving force for all the news and all the interest we see in generative AI. It's not good for everybody. I mean, how many of you seen this news? But Harvard University is actually using AI to teach one of their classes. It's a CS50. It's one of the most popular courses in the university. It's the first one that the computer science students are taking it, and they run that experiment. They never told the student that an AI is teaching them a chatbot. And it's an online class. So, and after they finished, they told the student that you've been dealing with an AI algorithm. And nobody noticed the difference. Basically, they have the same answers, or maybe better, when it comes to that class. And the class was Introduction to Computer Science. So there's not that much of complications about the answers. The other thing that you have to know a little bit about the famous tools we are using now. ChatGPT 3.5, which is the free one, is actually trained on 175 billion points of data. ChatGPT 4, which is the one you have to pay for, was trained on 1 trillion points of data. That means they fit it with all this information so they can make that decision. Meta, they have their answer to ChatGPT and called Llama, and specifically Llama 2.0. Trained on 2 trillion points of data. And the Google, they have Bard, and Bard is not doing well. Even some of the engineers that I know at Google, they're really expressing their, I want to use a better word. They're not sure that it's really something that compete with ChatGPT. And I did the experiment. I ran all of the chat bots here. the same question for 3.5, for Llama 2, and for Bard. And by far, the ChatGPT was giving me the most, in-depth answer and the most organized answer compared to the others. The others does just give you give you some answers which is around the point, and there's not that much information you can get out of that. Okay. I think the algorithm for ChatGPT is the key, more than just the data itself. Ernst & Young, the famous accounting or services company here, the consulting firm, they will invest $1.4 billion in AI. When you have a company like consulting firm, an international company like Ernst & Young, EY, they announce this, they say, okay, we're going to invest $1.4 billion. The key thing is that they will train their 400,000 employees to work on AI. And the future of this is so they can have, they save money because they will use less people. Most of their answers, most of the work will be done by the AI, and this is why they're saying that we're gonna do that. Now let's go a little bit technical, just to understand what is the concept here. Artificial intelligence is multiple layers technology. Inside the artificial intelligence, we, the past few years, we've been talking about machine learning, and then we dive deep into the neural network, and then we went all the way inside the deep learning, and then we found ourselves at the ChatGPT, which is at the heart of the deep learning, away from the CNN, RNN, and GNN or DBN. It's all those techniques, all those algorithms used for the deep learning. It's all used in the ChatGPT. Now, what was the driving force, or what were the driving forces for this kind of technology to have the big impact? And we see now there are three things. The first one is the increase in the computing power and storage. And when I discuss this with my students, I tell them that it's not that the increase in the computing power as much as it's cheaper. When you're talking about, yes, there is an increase in the computing power, at the same time you have the prices. I mean, you can buy so many of those devices or some of those chips compared to a few years ago. They're very expensive now. They're getting cheaper, and people can buy them. So this is what he's saying. And Moore's law also apply to that, which is you double the number of the transistors every 2 years. And then the data we have, and I'm going to show you a diagram about 1 minute on the internet. There are a lot of data that coming into our hands, given all the connected devices. In 2025, you have 50 billion devices. This is a conservative number. There's some numbers say 75 billion devices by 2025. And also the advancement on algorithms. When we talk about new algorithms that can use the hardware and can use the data, which is the fuel of the AI, the whole thing here gave us that inflection point where we are seeing the use of the graphical processing unit to train the deep learning models. And this is why you see this going on. Now, the Gartner, they have the famous IT or consulting term. They have their high cycle for artificial intelligence for 2023. And you can see, this diagram, it's just showing you that where is the generative AI in general. And we're talking about 2 to 5 years until we see, this technology is becoming mainstream, and we're not going to see more improvement out of that, but something else going to take over. We're looking at what is coming, what we're going to see in 5 to 10 years. What's next to this? I mean, the generative AI using the smart robots, responsible AI, prompt engineering, which is a very important topic here. Okay, so that's just a brief introduction about it. When I was asked about the AI, one of the first things that I explained, whether it's the media or the student or anybody who is looking at the AI and they say, what's going on? Why suddenly we are looking at artificial intelligence and talking about it all the time? You have to understand that there are 3 stages of the AI. There is the narrow and the general and the super. The narrow is the one that we just passed. The narrow is talking about Siri, Alexa, where the human is smarter than the machine. The general, which is the one we have now, is the human and the machine. They have a similar intelligence. Sometimes one is smart and sometimes the other one's smarter, but they are on the same level. The super, which is the scary one, this is when the machines are smarter than the human. In that case, when the AI start making their own AI, they start writing their own code. They start correcting their mistakes and the human is out of the loop. What is really interesting is the expectation for general intelligence was in 2040. We're in 2023, so we are ahead by 20 years. And this is why it's really caught the attention of so many people who are saying we have to be very careful. We have to have a regulation. We have to have some kind of rules that will control the AI. And this is why, because we are early by 20 years. What's going to happen when we're looking at the super AI? So there are a lot of different, types of generative AI and model. They use machine learning algorithm to learn and underline patterns here and generate the data. And they're using something like the GAN, which is the type of machine learning that consists of two neural network that together, they work together to generate new data. So you're talking about two of them. They're working together, just to get to that data. Generative AI, they have a lot of applications. We have seen them in so many things. A lot of the companies, they are using it as part of their customer service. They're using it. A lot of the employees, they use it so they can achieve certain goals. They can achieve the reports, can correct things. I use it on a daily basis. My students are using it in their research and to get the starting point to understand certain concept. It's used in healthcare. I was talking to this startup in Oakland, which is a a city which is about 20 miles from where I'm talking to you here in Northern California. So and they have this AI that will answer your question about the health, and the information is processed and actually taken from doctors. So now you're talking about something between Google search and between the real doctor. There's something in the middle, which is okay. Instead of just Googling this and get the information, I can use AI to get some more information, and this information will be verified by the doctors. Some statistics, some more statistic about the AI is about half of all the companies currently utilizing AI in some fashion. AI could take the jobs of 1 billion people globally and make 375 million jobs obsolete in 10 years. Those are the statistics about how the impact of AI on the job. AI or artificial intelligence will create 97 million jobs and generate about $15.7 trillion, by 2030. And by 2030, 45, and this is local to the United States, 45 million Americans could lose their jobs to AI automation. And this is about 25% of the workforce in the United States. That's why you see a lot of people are in the United States, they're scrambling to make sure that there is a replacement at the same time to make sure that we know that this is coming. This is not something that you can escape. So that's the first technology. The second technology is the voice user interface. Usually when we talk about the interfaces, we're talking about the GUI, the graphical user interface. We are talking about the touch screen, that is the interface. And or we're talking about, the command line, CLI. Those are certain things. But nowadays, the voice user interface, which is, I think, Amazon was talking about it in 2017. I remember that conference when they introduced that concept. We see it all the time. The reason for this is the VUI is one way for you to communicate with different devices without looking at the traditional way of a device between the software. Beside that, 80% of our communication is done through verbal, 80%, 80. And 20% is done by the other senses. So for the longest time, the companies ignore that 80%. and they focus on the 20%. Now they realize that. I mean, look at the sci-fi movies, look at Star Wars, look at the other movies. You're going to see that they talk to the robots, they talk to the machine. They barely touch those machines. And this will help us with the Internet of Things. When you look at a thermostat, when you look at a device or a camera, a security camera, you have to have the app. You have to download it so you can set up that camera. Why not just talk to the camera? You know, plug in the camera and then just set up the whole thing by giving the password, and the machine will talk to you back about would like to have it with this and this and this and this. And then you can just set it up instead of going through an intermediary here in this case. And this will rely heavily on the natural language processing technology, which enable the devices to understand and respond to human speech. And this will take us to the smart devices. The smart devices, and the definition of smart devices is actually built on 3 pillars. Number 1 is the AI. There should be some kind of artificial intelligence involved. Number 2, connected to the internet. That means that device should have an IP address. And number 3, there should be some kind of operating system that will run the device. And this is when we talk about how it's going to help us with the process here. Now, VU can be designed to understand a wide range of command, can use to control various functions. I don't have to do anything. Just my voice, the prompt I give it, and I can get the answer. Young people use this with Alexa all the time. They use it with Siri. They talk to Siri all the time, and so they're used to that. And it's very convenient. And this is one of the things that we're going to see more and more and more. The third technology is edge computing. And edge computing is really a very nice story we've seen here in Silicon Valley. It started in the 2000s with Cisco, and the name of this technology used to be fog computing, FOG. The fog, you see it in the morning, that was the original name. And then they changed it to edge computing. And the reason for Cisco to name this one as fog computing, because it's related to cloud computing. So if the cloud up, when the clouds start coming down and close to the ground, they turn into fog. And this is, you say, the devices will be close to where the action is, which is that's why we call it fog computing, and then they change it to edge computing. I'm one of the fans of the edge computing, because this is similar to having the federal government and the local government. Not everything should be done by the federal government or the central government. There's a lot of things you can do, a lot of decisions you can make based on the local government, where I don't have to go to the central government for everything. It can be done at the local level. And this is the idea of edge computing. It's distributed computing here, where you have to be close to the action is. Tesla factories is 10 minutes from where I'm talking to you here in Fremont, California. And Tesla, as an autonomous car, they have so much information going back and forth. They don't want to wait for the data center, which is in a different state or in a different country, to send them the response or make a decision. But if there are small data center, which is edge devices, where you can have them in certain places, then what you're going to do is you can make that decision faster. Because when you drive in a car, an autonomous car, and it's an autopilot, then you need split-of-second decision. You cannot wait, for seconds, to make that decision. In edge computing, data is processed and analyzed at the edge of the network, where it's generated, collected rather than being sent back to the center. And that's what we're talking about it here. Now, the edge computing will solve the problem of latency, sending the data and waiting for the answer. It's going to preserve the bandwidth, so not everything's sent to the center, where it's going to be really busy answering all those requests. So you're distributing this and where the action is. Netflix is using this. Tesla is using this. A lot of those companies who need this kind of a quick answers and quick reaction or quick decision making, they use it. And this is what I say here. It's basically reduce the latency, improve the performance, increase the scalability of the system that required real-time processing and decision. It's very helpful in when it's used with the Internet of Things. We see that a lot. The network instead of going to a central decision, a central location. The next technology is 5G, and this will be easy for us to understand. In 2018, I attended a presentation by Verizon about the deployment of 5G in 2020. And nobody knew that we're going to have COVID. So everybody is planning that 2020 will be the 5G year. And then COVID came and changed a lot of those plans. And without the help of Apple, introducing their 5G phone, the 5G would have been, still, a lagging technology. But nowadays we have it. The 5G network here, at least in the United States, is really deployed and in a big range. Google, AT&T, they paid, and other companies, and Verizon, they paid about $81 billion to the government so they can give them the 5G, that spectrum here. It used to be with the military, and then they push it on the civilian because they moved to another band. Back to that conference about Verizon, one of the things that I have learned in that conference 2 years before they release it is the question about why do we need 5G? I mean, with 4G, we have LTE is good. Why want to go to something which is just to watch videos? This is for entertainment? No, it's not. There are specific applications for this that could replace the Wi-Fi. That could help us having just the 5G instead of having all the wires or having all the access points and so on. They gave us an example. And that example was, imagine there was an accident on the road, and God forbid nothing will happen, and you have injured people. You took that person on the back of an emergency vehicle, and it's going to take you, 10 minutes average to get to the hospital. That 10 minutes could be a very crucial time in the life of that person. He or she could lose their life if there is no care, or if there is no way for you to take care of that person unless you get to the ER. Once we have the 5G, a lot of the equipments and a lot of communication can be very easy because of the wide bandwidth. The doctor can do a lot of things he or she will do in the ER while that person on the back of that vehicle. And that will save lives. Just an example about how is that going to be help us. Besides, having videos and having, and adding more customers, which is important for the companies to always look at it as their perspective here. And this is what we are talking. It's up to 10 gig per second. It's about 10 to, in some instances, 100 times faster than the 4G. So that's lower latency for the signals, more video streaming required, real-time requirement will be available there. Gaming will be also an option once you have the 5G anywhere. It's still, at early stages with deployment because you have to change the hardware. Because in order for you to get the benefits of the 5G, this is a whole industry is there about we have to have the hardware, and that hardware can use the 5G. Digital twins. If you're in the industry, if you ever dealt with the industrial Internet of Things, you heard this digital twin terms before. It's very interesting. And by the way, it's more common in Europe more than the United States. The United States is not that big fan of the digital twin compared, with the exception of big companies like GE and the other companies who are in the field of manufacturing. But in Europe, it's every time I talk to my friend in Europe, that it's a very common term. So what is digital twin? Digital twin is a digital copy of your factory, but it's not just simulation. It's actually connected to the real world, connected to the real factory. So you can try different things in the digital version, and then if everything is fine, for example, streamline the assembly line, taking one of the robots out and see what's going to happen. You can do a lot of studying, a lot of simulation here, and then after this one, you're going to upload it to the real world without disrupting the manufacturing process. And this is how significant is the digital twin. 45% of the factories of the big names, either they are using it or they consider using digital twin as a possible solution for improving the efficiency of their manufacturing process. So It's created by using data and sensor to monitor the performance and characteristic of the physical object or systems, and using this data to create a digital model that reflects it. So that digital model keep changing as you change the physical one, just to make sure that it's better. And there's a lot of application for that. Some of the application allowing doctor to better understand the patient condition, plan treatment, operation, identifying potential issues, because you can do all of these things on the virtual board and see what will be the impact later. Digital twins are created using a combination of sensor, data, analytics, and machine learning techniques. So that's the difference between this and simulation. They can be used to visualize, analyze behavior of physical objects, and that's to optimize the performance and also see what is the issue, why we have this supply chain issue, why we have this manufacturing, why we stuck, where's the bottleneck of the manufacturing, and make decision about it to improve it. And quantum computing. Quantum computing, the 4 technologies I mentioned at the beginning of the presentation, when I talk about Internet of Things, we talk about, blockchain, artificial intelligence, cybersecurity. They're the future for me. When I tell my students that when I do research, this is the future. If you want to do research, just think about the 4 areas and find your niche there. But there is a 5th technology that within few years, 5 to 10 years, it's going to change all of that. The reason for this is how powerful is this technology. One day, I did an interview with one of the radio stations in Korea and South Korea, and the the anchor was asking me about, can you give me an example about the difference between quantum computing and classical computing, in a way where it's going to be very clear to everybody without the complication of quantum mechanics and quantum physics, because it's a very complicated area, and anybody in that field understand that. Think about it this way. Let's say that you are trying to escape a maze. A maze is an area where you have doors. You open the door, you go to the next hallway. You open the next door, you go to until you get out of that area. That's the maze. Think about that situation. If you're in a maze and you're trying to get out of that. In classical computers, you open door and you go to the next hallway. You open the next door and next door you try. If there's a dead end, you go back and try to find another way for you. And you take it one by one. That's classical computers. Quantum computing will open all the doors at the same time. So if all the doors open at the same time, you can get out very quickly. And that's just to understand the difference between quantum computing and classical computing. In 2019, Google announced something called quantum supremacy, and quantum supremacy can be explained with a very simple statement. They proved that a mathematical problem or a problem, a computational problem, that you need 10,000 years with the current classical computers to solve it, because you need that the iteration, you can tell it's going to take that much time for you to finish it. Classical computers will take 10,000 years to answer. Quantum computing will take 300 seconds. And why this one is significant? Why? Okay, when I teach my quantum computing class, I tell my students, think about speed. That's what you should think about it, and think about quantum computing. Here's the killer application for that: encryption. The RS 1024 or 2048 that's used by the internet to encrypt our communications, our financial communications, our communication between the different nodes. Everything we're doing in the internet is using this kind of encryption. That encryption, the strength of that encryption is you cannot find the decryption key, so you can decrypt the communication and see what's going on, because it's going to take you a long time to do it. It's built on prime numbers, and you multiply them, and there's a process to do that. With quantum computing, you can do that very easy. So all the communications, all the financial transactions, all the secure communication we talk about, it's going to be exposed once we get to the quantum computing level, which can be used in a way where it's sustainable. And that's needs some number of qubit. Qubit is similar to the bit. in the classical computer, we have zeros and ones. In quantum computing, we have all of them. We have 0, 0, we have 1, 1, we have 0, 1, 1, 1, and 0 at the same time. And that's called in the qubit. That's the name of that process. Thank you. Thank you so much. There's some comment here. I appreciate that. Okay, so let's just give you this one. Here's the thought I want to give it to everybody, and I want you really to think about it, because this is something I talked about 3 years ago. The current situation of computing is built on math, and any one of you who is in that field, of engineering or computer science, understand that we are using Boolean algebra when we are using our current computers, which is zeros and ones, the gates, and all these things. We're getting to the end of that. We're getting to the maximum of that part. What is the next step for us? The next step is, instead of using math, which is used for the current computing, quantum computing using physics. And that is the basis of quantum computing. And that gave us this tremendous power, computing power. So what will be the future? So if we use math for the current situation or the current computing, we're going to use physics, which is, technically speaking, that's the building block for quantum computing. My belief that the next science that's going to be the basis for computing will be biology. If you look at the DNA design, you're going to see this is the most amazing storage technology that you will ever have in your life. So maybe in the future, we're going to talk about not quantum computing, we're going to talk something has to do with biology as the basis. And there are some experiments about this. I'm telling you that there's a lot of scientists going through this. I'm talking about we're going to go to the level where we have companies that will start manufacturing computers built on using the power of biology. As we consume math, we consume physics, now we're going to go to biology. The difference between quantum computing and classical computing is very visible, and this is the architects to show you the increase of complexity, compared to the abstractions we have with quantum computing. And also there are companies, I'm not going to spend too much time on it because I don't want to make this one as promotion for them, but quantum computing is a reality, and there's a lot of companies actually working on this. So it's still in early stages, and that's another one. The next technology is chatbots. Every student who is doing his or her capstone project or their senior project with me, I tell them that you have to include an API for ChatGPT or Bard, whatever you want, but you should have some kind of a chatbot that will help in the final product of your project. I'm not going to accept it unless there is a flavor of AI in your project. In the market, you go there and you talk to the recruiters and they want to hire you. When you think about it, they look at it and say, have you done anything in AI? And it give you an example. Anthropic, which is a company that supported, or still actually, Amazon is supporting this company. It's a competition to OpenAI. OpenAI is the company that released the ChatGPT. Anthropic is a San Francisco company. Amazon gave them $4 billion to continue their research. They announced jobs for AI positions, and I'm talking about product managers, all of these things. And the salaries in an annual base, yearly salaries is close to $500,000. And if you look at the requirements and all the things, AI at the heart of that. Netflix, last month, they announced that they're looking for an AI expert, and the salary of that person, the yearly salary for that person is $900,000. And Sony Entertainment, they have exactly the same position. They're the competition of Netflix. And they said that we're going to give $1.2 million every year for anybody who will take that position. So having AI involved and in everything we're doing, it's going to be part of our life. You're going to see that the term smart. This is the key thing in this process. Okay, so VR and AR, struggling technology. trying to find ways. The problem with the virtual reality is, it's covering your eyes, so you're isolated from the real world. The augmented reality, which is you still can see everybody, but those virtual object is imposed on on the world, so we can see them. Microsoft is a leader in that, where they can in the class I can just show you the object and I can move it in front of you while you can see me as I can see you. When you mix them together, you get the mixed reality, and this is one of the technologies that Apple is trying to solve, that intercept between VR and AR. And their latest goggle, you can switch it. You can switch it between AR and VR, and that's really a smart thing. Is they have something I think close to 16 cameras. Some of them inside watching your eyes. They have a lot of speakers. There's a lot of software there. It's an expensive one. One of the engineers at Apple was talking to him 4 weeks ago about it. He said, they're developing that. They understand that this is expensive. They're trying to find a way for making this one as mainstream. And that's the difference between the two. Okay, let's talk about the blockchain. And blockchain is under the umbrella of distributed ledger technologies. I'm a big believer in blockchain, but let me clarify one thing here. It should be clear to everybody that there's a difference between blockchain and cryptocurrency. Blockchain is like the electricity, and cryptocurrency is like one of those appliances, like a stove or a microwave that uses this electricity to give us some kind of products. You cannot blame electricity if that device is faulty. If there is a problem with that device, we will have the electricity can be used for good, it can be used for bad, it can be used for so many things. But the same thing, electricity is very essential. So blockchain is the new electricity when it comes to the technology, because of its nature of making sure that the data is secure and you cannot change it. Now, some of the information about it, and I'm going to go through some of the information because I think I'm hitting the clock, in a few minutes. Let me go through okay. So what is blockchain? Blockchain is a software, and that will make things much easier for everybody. The best definition of blockchain is given by a professor from MIT. It's a cryptography and human logic. Cryptography is the username and password, and the encryption algorithm. Human logic is the distribution of the data. So copies of this data will be in multiple areas, just in case we have 10,000 computers have the data. If 1,000 of them got hacked, you still 9,000. That is really safe. And there is a mechanism between them to make sure that those 1,000 are gone. The components of the blockchain is the cryptography, peer-to-peer network, consensus mechanism, that's the agreement among the nodes, the ledger where you have the information, and the validity rules, which is the smart contract. Smart contract is a very nice way or a very nice upgrade to the blockchain. Just a very quick information about how the blockchain works. This is one computer. Node means one computer. You have your information, and it's a software. You enter this data, and there will be an index and timestamp and the hash of the data, and you will hash, basically you encrypt this data, and then you save it in the next block. The next block will have their own data, and then they will hash it or encrypt it and save it in the next block. So this is why they call it blockchain. So if anything changes here, everything after that then will be invalid if somebody tried to hack in that. Why? Because node 2, computer 2, and 3, and 4, and 5, and 1,000 computers have the same information, and they use something called gossip protocol that will sync the data. If one of the computer has a different data, they're going to isolate that computer, and they say, you don't have the same data as us, so you cannot be part of the network. The blockchain programming language is any programming language. I mean, the famous Bitcoin is actually built with C++. And I use Solidity in my classes when I'm teaching blockchain. It's the programming language with smart contracts. It's similar to Python, very easy to understand. And that's one important thing. And also the tracks of a blockchain, which is pure R&D, what we do at the university. Excuse me. immediate business benefits for, which is what the businesses using when they start using the blockchain, and then the investors when they look at the future of blockchain. The types of blockchain, you have private one that the companies will establish themselves, or public, which is exactly like Bitcoin and and Ethereum, all this example of that, and federated or hybrid, which is mix of both of them. Now, how you compare blockchain to database? Very quickly to understand it, and if you took any classes in database, you understand the terminology here. This is a list of it. I'm going to pick 1 or 2 or 3 of them just to show you the difference. The cost is high for the blockchain, while it's low, and performance is slow because you have to get the confirmation and the same copy in all the different nodes. For the database, it's very fast. The nature or the architects of the blockchain is distributed, while in the case of the database, the traditional database is client. And also the blockchain is read and write. If you write something, you cannot change it. You're done. You only can read it. Not the case with the database, which is something like the CRUD. We talk about it: create, read, and update and delete. The next technology is Internet of Things. Internet of Things, just to understand the significance of Internet of Things, just look at this 1 minute on the internet. You can see all the numbers of the apps that is available, on the internet. I'm gonna tell you that, for example, Amazon is making $283,000 in 1 minute, just Amazon sales. And this and the Snapchat, there are 2 million Snapchat in 60 seconds. And the same thing goes with TikTok, 167 million videos watch in 1 minute. That's how many people are watching at the same time. Netflix, there are 452,000 people watching in 1 minute. Now take this and multiply it 1 minute by 60. That's 1 hour by 24. Take one of the numbers here, and then by 30, give you 1 month. By 12, that's give you a year. You're gonna understand that how big is the data we have on the internet. This is the driving force for it. The inflection point for the internet is actually happened in 2008 when Steve Jobs introduced the iPhone. That was the introduction point. And there is a fun fact about it. I don't know how many of you noticed that when you buy the iPhone, you look at the cover of the box, and you notice that there is a number called 941. That number mentioned all the time. That is the exact minute when Steve Jobs introduced the iPhone. They kept the clock on that minute. And then after that inflection point, the devices, the smart devices, went through the roof. 50 billion devices in 2020, and 75 billion devices according to Cisco in 2025. The Internet of Things is part of the Industrial Revolution number 4. It's the 4th one, and that's we went through the first, the second, the third. We are in the 4th one, and the application for the Internet of Things is huge. And I'm not going to go over all of it, but there will be a copy of this presentation. I'm going to send it to my friend Erol about it, and he can share it with you guys, the ladies here too, if you'd like to get a copy. But let's give you some of the applications here. So the Internet of Things is really covering a lot of areas in this sense. Okay, I think I am hitting the clock here. This is the references, and this is my LinkedIn profile. I'll be more than happy to go to the next stage. I'm gonna leave this one on the screen for you guys. This is my email, this is my LinkedIn. Feel free to contact me, or if you have any questions.
Professor Banafa,
Yes.
I'm very thankful. First of all, thank you for your friendship. I'm also thankful on behalf of Istanbul Aydın University, Blockchain Academy, Blockchain Talks, because I know very well personally you are very busy, and I know it's very early still in US, and you dedicated your time, your private time for us, for our university, and your all the participants. I'm thankful. We learned a lot from you. We thought of many things that we know, but we knew, but now we know that we know now after your explanation and sharing your really very valuable information with us. We hope to see you soon in person in our university, Istanbul University, as our guest lecturer or guest speaker. And thank you for everything you did for us. And
Thank you so
we
much.
know we know that you are the thought leader. I know very well, and now the participants know too, and we know the reason. Thank you very much.
Thank you
Thank
so
you very
much.
much, and enlightening us with your full information, full knowledge. Thank
No
you.
problem. Thank you so much. And thanks to everybody for coming. I really appreciate that. And you're my friend. And if you have any
Take care.
questions,
All the
guys,
best.
let me know. Okay. Have a good day, everybody. Thank you so much for the invitation.
Thank you very much. All the best. Bye bye.